In the last video, we talked about solving systems of equation using graphs. This time, we're going to be talking about how to solve system of equation using substitution and elimination. So there are three ways for solving: graphing, substitution, and elimination. So let's start with a warm-up problem to kind of get an idea of what we learned last time, which is graphing linear equations and estimating their solution. So graphing has its limitation because when you're drawing a graph and finding a solution that way, you're dependent on your drawing and the accuracy of your drawing. So first off, you have two equations, and if you were to graph them, you can see that you don't need to solve for the y because the y is already by itself. So step one is usually to solve for y, but y is by itself. Step two is to graph the lines using the y and x intercepts. The y-intercept and the slope. So my y-intercept for the first one is at -5, so that's right here. And my slope here is 2, so my slope is 2 over 1. So if I go up 2 over 1 and just continue that trend, I'll have my graph. There we go. And so I have my line here, and if I were to graph my second one, has a y-intercept at -1, as you can see here, and my slope looks like it's also 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. And so when I draw the dots, I start to notice that these two lines are parallel. And if you look at the equation, notice that their slopes are the same. So this is definitely parallel lines. And if you have parallel lines, you notice we didn't get any intersections. Parallel lines never intersect. So if that's the case, this won't ever give solution. So these two sets of lines will never intersect. So there's no interceptions, no solutions. All right, let's get into our next type of method, which is substitution. So substitution is where you choose one of the equations and then solve for one variable. Then you'll use that variable and plug it into the other equation to help you solve for x and y. So let me demonstrate what I mean here. So notice I have a system of equation. This one's a little bit simpler because this second equation only has, the y is already by itself and it only has a 3x. So what I do is, given the two equations, I choose one of the equation to solve for one of the variables. Lucky for me, one of them's already solved. This equation here, the y is already by itself. So what I do next is I plug the equation. So I'm going to take this 3x, because that's what y equals, and replace it in the other equation. So here's what I mean. So since 3x equals y, that means I can replace this y with 3x. Why would I want to do that? Well, it's because I want to make sure that when I solve for an equation, there's only one variable. So I don't want I want this to either have all y's or all x's. So because I know y is equal to 3x, I'll replace that. So this can be, instead of y, a 3x plus 2x equals 10. So this is the first equation, right? And so now y is being replaced with x, and now all the variables here is just x. So if I were to solve for it, it's much easier to do so when you only have one variable. So that's the key. Get it down to one variable in one equation to solve. So I'll combine these two. 3 and 2 make 5x. This is 10. Now I'm going to divide by 2. That cancels. So x is equal to 10 divided by 2 is 5. So once you get your x value, you can take this x value and plug it into either of these equations and solve for y. Now for me, I know that the second equation would be easier to choose because the y is already by itself. So if I plug in 5, all I have to do is multiply it with the 3, which gives me 15. So now I have my two solution, and this is actually a coordinate because it's an x and y value. So my coordinate here is at 5, 15. Here's the x, here's the y. I also want to mention here that because it's just one coordinate, these two lines intercept, at 5, 15, which is the intersection coordinate. So there is only one solution because there's only one coordinate here. And that's it. All right, let's try another one here. So for this one, I want you to notice that both y's are by themselves. So both y is already by itself. So this one's a nice one too. What you can do here is take one of the equations. So I'll just take the bottom one here, and you can set the equal to what the y, where the y is. So I'm going to replace this y with whatever it's equal to. So 2x plus 8. 2x plus 8 is equivalent to 5x minus 10. Since both of them equal y, you can set them equal to each other and solve. And notice like this equation here just has x's, which is good. So once they are set equal to each other, you're going to try to get all the x's on one side and all the y's, all the x's on one side and all the numbers on the other. So maybe I will move this 2x over to that side. So I'd have to subtract off 2x. That leaves me with 8 equals 3x minus 10. I need to add 10 to both sides to try to get the 10 off. And so this makes 18 equals 3x. I'd have to divide by 3. And so x is equal to 6. So now that I have x by itself, I can take this 6 here for x and plug it into one of these equations. It doesn't matter which equation you choose. They should give you the same answer. So I'll just choose the top one for convenience. So if I plug it into the first one, I have 5 times 6, the 6 that I found for x, minus 10. So if I multiply these two, 5 times 6 is 30. 30 minus 10 is 20. So I have my x, I have my y. Remember, those are coordinate points. That's a pair. And this would end up being written as 6 first because that's the x value. X always comes first. Or basically go alphabetical order. X comes before y. You don't need to write x and y, but sometimes that helps to remember what order they are in. And because it's just one coordinate here, this is just going to be also one solution. And that's it. All right, let's try out one more before we end this video here. So this one here, I want you to notice that both equation, the y isn't solved. So this is where I'll choose one of the equation to solve and try to get y by itself. So for me, I might choose the top one here because I noticed that there's less things to move around. Like I only have to move around this 5 over and then y would be by itself. Whereas this one, if I move the 3 over, I still have to get rid of that negative 8. So the top one's a little bit easier for me to navigate. So what I'm going to do here is I'm going to grab the first equation, the top equation, negative 5x plus y. And I'm going to try to get y by itself. So that means I need to add 5x to both sides. So that cancels. Y is equal to negative 3 plus 5x. They do not combine, so I just bring it down. And so now I have y by itself. And I'm going to try to take this y value and plug it into the other equation and then try to solve it out. So it's going to get a little bit messy, but just bear with me. So I have 3x, this 3x minus 8. But instead of this y here, I'm going to plug in negative 3 plus 5x. And when I do that, it's really important to wrap it around parentheses so that way you can make sure you distribute that negative 8 properly. So instead of the y, I have parentheses negative 3 plus 5x because that's what y equals. And so from there, I'm going to bring down the 24, the equal sign and the 24. And so when I look at this problem, I'm just going to try to combine all the x's and the numbers. So first off, I'm going to distribute the negative 8. So this makes 3x minus, well actually, that's not a minus. Negative 3 times negative 8 is positive 24. And negative 8 times positive 5 is negative 40x equals 24. And so from here, let's try to combine some like terms like 3 and 40x combined to give you negative 37x. And the 24 here, I'll just bring that down. So 24 minus minus 37x. Bring down the 24. Now, since this is 24 here, if I move this over, I subtract it off, it would cause the other side to also end up being 0. So this would end up being 0, and then I would divide over negative 37. Now, if I divide over negative 37, this 0 on top, 0 divided by anything, just gives you 0. So x is equal to 0. Now I need to find y. So what I'm going to do is take this equation and plug it into one of these equations. It does not matter which one. I can even plug it into this equation here. But like I said, it doesn't matter. So I'll just choose the top one. So in the top equation here, I have negative, do this part in green, negative 5x. I know what x is. It's 0 plus y equals negative 3. Well, if I multiply by a 0, they cancel because that just ends up being 0. And so y equals negative 3. And so I have my x, I have my y. I can write this as a coordinate system. And so that would be 0, negative 3. And because it's one coordinate here, this is going to be one solution. And that's it. So hopefully you found this video to be helpful. In the next video, I will explain how to do elimination. Let me know if you guys have any questions. Bye, guys.